Okay, this is video 2. This is the bottom of page 589, looking at example 1, and I hope that y'all will feel very blessed because this is my second or third attempt at this one video because I keep knocking my phone off the pedestal. I'm so sorry. It's hard to move it around, keep it where it needs to be, focus on one thing, then move it to another. So if it falls off this time, we are just going to have to plug on, but I apologize in advance. Sometimes when I have to get it on the page of the book to really see what we need to see, it's not flat enough, and that's what causes it to tilt. So bear with me. All right, example 1, letter A. We are going to just find the measurement. They want us in A to find the area of the parallelogram. Let's come look at this parallelogram. You know what? I'm going to sit here trying to move my book around more than my phone. Okay, there we go. Here's our parallelogram. You can see that in this parallelogram, originally, I'm going to cover that part up. Originally, we were given a base. We were not given that. I wrote that in. So we were given a base and a slant height. But we cannot solve area with a slant height because height must be perpendicular to base. Y'all have to remember that. Super, super important. Height must be perpendicular to base. Okay, so what we have done here, or what they did here, is they took a little triangle right here and they cut it off and they relocated it right here. There were 3 inches right there and they put the 3 inches right here, and now instead of having a parallelogram, I'm covering up that end of it, we now have a rectangle, just a normal rectangle, and we can solve for that height. I've already done it, you can see, but that's what we need in order to eventually find the area of this parallelogram that we have turned into a rectangle. So remember, the formula is the same for both, and I just showed you why, because we can turn parallelograms into rectangles, and the formula equals base times height. So let's start with our little triangle and solve for this height. You'll notice that we can use the Pythagorean theorem because we have a hypotenuse and a leg, and we need to solve for the other leg. So we say a squared plus b squared equals c squared. 3 squared plus h squared equals 5 squared. That is 9 plus h squared equals 25. H squared equals 25 minus 9, which is 16, so h equals 4. We now have our height, and we are now able to solve for our area, as you can see right here. Area equals base times height. Our base is 6. As you'll look at this and see, the original base is 6. The only reason we have the 3 there is to show what we moved when we flipped it, or actually we didn't flip it, but when we carried it around and laid it back down, because we needed that number in order to solve for the height. But the original base is simply 6. And so we multiply our base times our height, which is 4. Our area is 24 inches. All right, inches squared actually, because this is area. Okay, flip the page. This is where I am at great risk of knocking the phone over again. And we are on page 590 at the top. Now we're going to look at letter B. And they want us to find each measurement that we're asked for. In B, we're asked for the height of a rectangle, in which B, or the base, is 5 centimeters, and the area is a little bit complicated. It's 5x squared minus 5x centimeters squared. So here are our 2 givens, the base and the area. Let's simply go plug those in. We're finding the height of a rectangle. So our area, as you know, will be area equals base times height, or length times width would work there. Same thing. All right. For area, we're plugging in 5x squared minus 5x, which is what they gave us. For base, we're plugging in 5, which is what they gave us. We simply need to solve for height. So we're going to simplify this problem. We can take a 5 out of that by dividing it by a 5, and then we're left with 5 outside of x squared minus x. So basically, we factored a 5 out of both of those. And now you'll notice we have a 5 on the outside of both problems. We can divide this problem by 5, and it's going to get rid of those. We're left with x squared minus x equals h. So we've done a lot of simplifying here. X squared minus x is our new height. We are done with that. The height of this problem is that. It's as far as we can go. x squared minus x. Now, you might be thinking, do I not need to factor an x out? Well, you could. You could factor an x out of x squared minus x, and you would have x outside of x minus 1. And that would be the same answer. That would be perfectly appropriate. Okay, let me erase that, and let's keep moving. Letter C says, find the perimeter of the rectangle. Here's your rectangle, in which area is 12x feet squared, and you see that I've written that there, and I'm looking to see what else. And we're given the height, which is 6. We are simply going to use our area equals base times height formula right there, and we're going to plug in what we know. We know the area is 12x, that was a given. We know the height is 6, that was a given. We're going to divide both sides by 6, and we're going to be left with the base equals 2x. That was simple. I've labeled it in our rectangle. And now the last step says use the base and height to find the perimeter, because that's what we were originally asked. So now let's find the perimeter. Well, the perimeter of a rectangle is going to be side plus side plus side plus side. Remember, perimeter measures the distance around. So in this case, another way to say it is, we have 2 identical sides here and 2 identical sides here. So we could lump them together. We could say perimeter equals 2 of this plus 2 of this, or 2 times 2x plus 2 times 6. Let's look at that. So we have perimeter equals 2 times 2x plus 2 times 6. Perimeter equals 4x plus 12 feet. So that should be pretty easy. All right, let's move on. We are going to scoot down to this next section. Actually, I think I will stop here and go ahead and restart the third video.